And now we are going live with our next speaker, Markku Lepisto, who will be joining us from Japan.
Hello,
Uh,
Marco.
Yay!
Hello.
Hello, Markku. Welcome.
Thank you.
Welcome.
Köszönöm. Sziasztok.
Yeah,
How's
Yeah,
everyone doing?
yeah. What time is it over there?
It's 9:30 p.m., but it's all good.
Woohoo! Awesome.
okay.
Then great timing. Well, we're really happy to have you here, Marco, and we've been pretty excited to hear from you and you sharing about the latest developments of applied AI. So please feel free to start now. You can have the
All
Yeah,
right.
it's all yours now. Go ahead.
Please make me full screen. So there we go. So thank you again for inviting me to this event. My name is Markku. I'm a solutions architect working out of Tokyo, Japan, and I work in the applied AI area with IoT, Internet of Things. So I work with these kind of funny little things. And I'd like to talk to you about creation today, how you can use AI to create something new. So let me show you some examples of that. So my presentation today is about edge AI in the real world. And I've been creating different kind of AI examples. Well, for example, I've created an AI traffic camera with SigFox, and then for a very large global bank, on their request, I created a stamp analyzer, analyzing what stamps were used to stamp documents. And then recently I made an AI sports analyzer that was analyzing my running cadence from a drone footage. So those are all fun and good, and most of them are based on some real business needs from actual customers. But for this event, I actually wanted to create something new. So I made a challenge for myself. Could I create a new AI solution in a couple of days for this International Women's Day Budapest 2021 event? So that was my challenge that I gave myself. I've been a little bit busy in the last couple of days coding, hacking away, and I'd like to show you what I built, and let's hope that it works. So the problem that my solution is trying to solve is the following. We have a very cute problem. Let me show you. So at our house we have a new visitor. His name is Oreo. That's what we've named him. Oreo is a little street cat that suddenly started appearing at our house, and he looks a bit small and scared, as you can see, running away. So we've started feeding him. But there's a bit of a problem that, of course, sometimes we are not there. So if we are not there, sometimes Oreo is waiting in vain, hoping to get some food. So it's a really heartbreaking, sad situation. So I was thinking, how could we use Edge AI and Google Cloud to help Oreo? So let's take a look. I had a hypothesis, I had an idea that maybe Edge AI, so running AI in the real world, would somehow be helpful for little Oreo. What if we could apply machine learning and AI to this problem? The problem is there a cat on the terrace? Is Oreo there? So I would like to be notified if Oreo is there. So what if we try to build something like this? A smart home, so make our home smart, by having animal object detection, detecting automatically if certain objects are there, in this case Oreo, the cat. So the end-to-end solution should look something like this. On the left you have the object, you have Oreo, and then of course we need a camera. Now normally legacy cameras, as you know, like this one here, my Panasonic GH5, it's a great camera, but it's not smart in a way. It's just reading this image that you can see, and it's transmitting the image. So then you need someone to look at the image to know what's going on. So okay, there's a guy waving his hands. So that's semantic knowledge of this image. The camera, in this case, my GH5, cannot do that. It's just passing the image on for analysis. But if we want to use AI, basically we could attach a computer brain to the camera that is automatically analyzing the camera picture. Is there a cat? Is Oreo there? And if Oreo is there, then the camera, the AI-powered camera, could send a message to the owner, like me in this case, that now there is a cat. So instead of sending the raw data, we could send highly actionable semantic data, which is the AI machine learning inference result. So what do we need to build this? Well, we need the object. We have Oreo. We have a camera. We can use any camera for that. I will just use a cheap webcam. Then we need a machine learning model that can detect cats. And because we want to run the model at the edge in the real world, we need something called the machine learning accelerator. Machine learning is rather heavy, so people were using things like GPUs, but nowadays there are machine learning accelerators that are specifically designed to run AI models on small devices. And then we want to have notifications. If Oreo is there, I would like to know about it. Okay. So first we need the machine learning model. Recently, Google announced through their Coral machine learning product line that there's a new model called Mobile Det SSD Lite. It's an object detection model that performs better than the previous models. And as you can see in this example blog post on GitHub, you can see that it can detect, for example, cats. So that's good. We can use this model then for our purposes. Then we need to run the machine learning model somewhere. So because I work at Google, I chose to use the Google Edge TPU, which is a very small machine learning accelerator chip that can run machine learning models very efficiently. So in this case, I can run it here. So this is the Coral development board. It's a little prototyping board used for developing these machine learning AI solutions. And it has the Google Edge TPU accelerator in there. And I can connect the camera to this one. So okay, let's do that. So this is my actual goal. I would like to receive a message from Oreo when he comes looking for food. And I would like to verify that he's actually there by seeing a big picture of Oreo if he's there. So somehow the camera has to know that A, Oreo is there, and B, be able to know where is Oreo in the picture and take a picture of Oreo and send that to my phone. So that's the end goal of this solution. So let's test this first. So as a first test, I simply took some video of Oreo on the porch with my phone. So there you can see the happy cat, he has just eaten. So okay, that's the training video, if you will, for machine learning, the test video. Okay, now let's run the same video through this, the Google Coral development board with the Edge TPU machine learning accelerator with the Mobile Det machine learning model that is supposed to detect cats. Let's see what happens to the same video. So when we process it, there we go. We can see that now the machine learning model is able to detect that there is a cat. There's a confidence, it's about 76% confident, and it's able to tell us where in the frame is the cat. So step one looks okay. We have a machine learning model and we can use the accelerator to run the model. So now we need to connect the camera to this board. So let's do that next. So the solution is then to build this Edge AI camera. And literally what I did was I just placed the webcam like this outside the window where Oreo usually is, and I connected the camera to the Coral development board. And I loaded the machine learning model there, and I started streaming the camera image then through this development board. Let's see what happens next. Let's see now the AI pet cam in action. So now I will move to the live demo. And give me just a second. Now, at the risk of making all of you run away, I will slightly show you a bit of the code here, but I promise you only a little bit. But the main idea here, why I show it, is to show that it's actually quite easy and fun. So this is the code that I wrote in the last couple of days for detecting Oreo. It's Python, it's the only language I know besides English and Finnish. So it's very simple. I'm not going to really go line by line, but I will just roughly tell you what this does. So this is running on the board. We basically start reading the webcam image. We stream the webcam image. We run machine learning inference, so we pass the webcam image to the machine learning accelerator. We get back objects that are detected by the machine learning model, hopefully cats in this case. And then all I do is start looping through these video frames. And if there wasn't a cat earlier, Oreo is not there, then suddenly Oreo is there. That's a change. I would like to be notified of this change. So if no cat first, then yes cat, then transmit a message. Oreo is there. Vice versa, if Oreo was there and then he goes away, I would like to be notified that Oreo went away. So those two things. We transmit a message when Oreo is there and when he goes away. So in practice, this board here has then a client to Google Cloud. And specifically, our service called IoT Core, which is coming from Budapest. So our IoT Core from Budapest is our service for connecting securely devices in the edge and connecting them to Google Cloud. And then the devices can transmit data. And in this case, the AI PetCam can then transmit the information, semantic information, there is a cat or there isn't a cat, and maybe even a picture of the cat. So the image and message will be received by IoT Core, and then it will drop the message to our global message queue pops up, and then I will handle the message with Cloud Functions. I don't want to run any servers. Short version, Cloud Functions are serverless computing for executing small little things. If there is a message in the message queue, house data, then execute a bit of code. And in this case, all I need to do is to store the image of Oreo that we received from the camera to cloud storage and also send a webhook message to Google Chat. So I made a Google Chat room called AI PetCam, and here I added a webhook. With the webhook, we can post messages programmatically to this room. So I would like the AI camera solution to post a message to that room so that my phone can actually receive messages if Oreo is there. Okay. And the files, the images of Oreo sent from the field are then landing in Google Cloud Storage. So quite simple, IoT Core, Cloud Functions, storing image files in cloud storage and then posting messages with webhook to Google Chat. Now let's see if that actually works. Let's put this device to the test. So here we are on the Coral development board. And then you saw earlier that I was showing an example of analyzing the phone footage of Oreo. Well, let's see what that looks like if I run the phone footage of Oreo through my app. So I will start running the app on the Coral development board, and this is the output of the Coral development board. So now you can see that the app is analyzing frame by frame the footage from the yard, and using the object detection machine learning model and detecting that there is a cat, we can see here that the cat confidence is about 76% confident that it's a cat. And then we also get coordinates where the cat is. And then I simply draw a green box around those coordinates. That's Oreo. Okay, so that worked. So that was a local test. We were running the data locally here with the camera connected, but we want to transmit a message to my phone. So what I'd like to do is if Oreo comes to the backyard, that's an event. Then we take a picture of Oreo using the bounding box, the green box you saw. Let's crop that, send that to Google Cloud IoT Core and all the way to the chat room with the message that Oreo is here. So let's see if that works. So we run the same test again, but I just add one switch. I want now the app to send a message to Google Cloud if it detects the cat. So I add the switch IoT. let's start the same thing again as before, but now we connect the device to Google Cloud, and this is a live test. So now we can see that, okay, the cat is there, and now if we look at the app here, it says creating a short token, connection accepted, transmit complete. So something has happened. And now when we go to the chat room here, you can see Oreo is saying, I am here. And if we look at my phone, we go to my phone here, open my phone and go to the same chat room. There we go. Oreo is here. So we got a real-time message to my phone from the AI camera. And the AI camera selected the best picture of Oreo in the last 3 seconds of the cat being detected. What is the best picture? I chose the video frame with the highest confidence that there is a cat. It's 24 frames per second, 3 seconds, so that's almost 100, something like 76, whatever, frames. And each of those is analyzed with the machine learning model, and each of them has a confidence. How confident is the model that there is a cat? This is the most confident frame. So it's the best image of the cat. I just cropped it and I sent it to IoT Core. Okay. Now let's do some other tests. Let's see some other videos of Oreo. So let's analyze the second video and see what happens. Go back to the development board UI. So this was earlier. I was trying to attract Oreo to come back. There he is. You can see he's coming. He's attracted by the food. Oreo is coming. And now on the app we can see transmit complete. Cat wasn't there earlier. Cat is there now. We go to the chat room and Oreo says, I am here. And indeed he is there. So he's happily eating and munching away there. And if we look at my phone, yes, we got the second message. Oreo is there. Okay, let's do one more test. Let's break this video analysis. And let's see what happens if Oreo leaves. If Oreo goes away, that's another delta, that's another change there. Was a cat earlier? There's no need to keep saying that the cat is there all the time. Until he goes away, I'd like to be notified that Oreo left. Especially if I'm not there, it's a bit heartbreaking. Okay, so let's go back here and analyze a video that I took of Oreo leaving. So let's start analyzing this. Let's see what the footage looks like. So there's Oreo. And then he's walking away, Now he left the scene. We go back to the app here. The app says Oreo left, transmitting a message to IoT Core. And when we go to the chat room, it has already sent the message, bye-bye. So Oreo is saying, bye-bye, he has left. So there we go. So that is an AI pet camera. And just to recap what it looks like, basically we just built something like this. We have the cat on the left. We have a standard camera. We are running a machine learning accelerator with the machine learning model, able to detect cats. And then we send highly semantic, actionable insights to Google Cloud in this case, and then forward them to my phone that a cat is there. All right. I really hope that you enjoyed this short presentation of Edge AI. I literally wanted to challenge myself to see, can I build a new solution on Edge AI specifically for this event? And that would be something fun, maybe more fun than detecting stamps or broken parts in a production line with AI. So I hope you enjoyed this, and maybe there are some questions that we can go to now. And thank you very much for your attention.
Wow.
Thank you,
Markku. Thank you for joining us today and for this really great presentation. It was great hearing from you. And yes, so we'd like to see if we have any questions here from our attendees. Here's the first one. It's up by Charos Abdukayumova. The question is, which algorithm did you use for stamp clarification?
Oh, for the stamp detection, I actually used Google Cloud AutoML, and I created a custom model. So this stamp detection problem was sent to me by a very large bank. So they asked me, could they use Google AI to detect which stamps were used to stamp different documents? And I've actually made a YouTube video on that where I highlight how I used Cloud AutoML to create a custom model detecting the different stamps. So if you go to YouTube and you look for Google Cloud Level Up, one of these episodes will be about this custom model generation. It's actually my latest episode. So please try to find that one, Google Cloud Level Up.
Awesome, and we'll try to share from here also. Thank you. And let's see, what else do we have here? So everyone's very happy and they're saying very cool presentation. Thank you. I think it was pretty exciting. And we have a comment from Big So John. It was a very exciting project. I hope Oreo was also happy in the end. So that's a comment.
Oreo was very happy because I had to keep testing Oreo coming and going so that my AI camera works. So he got a lot of food because the only way to get him back to get a new recording was to give him more food. So that was a good day for Oreo, I think.
I think so too. That's cool. Okay. Well, do you have any more questions? Oh, we have more questions coming up, so we can ask that up. We have it from Margarita. The question is, how would you go about fine-tuning this model to distinguish between Oreo and other cats?
Yeah, that's a great question. Actually, thank you so much for asking that. I should have said that. I was planning to say that, but I forgot. So I used a so-called standard model or pre-built model, which is the mobile debt model. It's a very well-behaving model, but it only knows cats. So every cat is a cat. But there is another cat here. So if I want to classify between these two different cats, I would need to use something. I would need to create a custom model. In machine learning, generally people would do something called transfer learning these days, which is a bit complex to explain, and I don't even understand it. But machine learning has a neural network that is trained with signals. It's able to detect the signals. A cat has a different signal in the image than a dog. But then if you want to detect between two different cats, you need to retrain the model. The model already knows what a cat looks like, and what a dog looks like, and what a boat looks like, and a car looks like. So there's no reason to retrain the model from scratch to detect cats. It already knows a cat. So what we can do is something called transfer learning to retrain the last layer, the kind of smartest layer of the last step in the neural network that can then classify between 2, 3, or 10 different cats, for example. In practice, this means that you will need to provide training data. So you would take videos or pictures of these different cats and then give them to a service or train the model yourself. And these are examples. They are labeled training data. Now, Google Cloud has a service called AutoML, which I'm a big fan of. With AutoML, you just provide these example images of the two different cats and you say, do it. Train the model for me. It will figure it out and it will create a custom model. So that's actually something I recommend that everyone could try. It's really fun to make these custom models. Sorry for long answers.
No, that was great. Thank you. Thanks for that. And we'll just check if we have more.
I would like to thank you for dedicating the time for this project, for our event. It's such an honor for us to have you here and to share this knowledge with us.
Yeah,
yes, of course.
A very exciting project, absolutely. So thank you, Markku. And if we have more questions, I guess later on we can pass it through again. Thanks again for joining us, and we hope to see you again.
Thank you. And I'm, by the way, very delighted that the next presenter after me is my friend Stephanie. So this is a first for me that we are presenting in the same event. So So over to you, Stephanie, then. And thank you,
Yeah.
everybody.
Thank you.